Good afternoon, class. I hope my screen is visible and I am properly audible. Okay. Last lecture we have started basic idea about the unit 4, that is structural modeling. So let's begin again once again with the start. So today we are going to focus So with respect to the object diagram, we need to understand the various scenarios. So let's focus on that. What are the various scenarios and how we are going to discuss. So just a second. Okay. So we have started with the structure modeling with UML, where we have discussed already. We have discussed about the classes, different types of relationship. That relationship starting from unary relation, that is simplest relationship called as what, association. Then after the association, we have discussed is a part of relationship known as composition, known as aggregation. Then we have discussed some common mechanisms to draw the class diagram, then how to draw the basic class diagram, then different interfaces for the class diagram based on their roles and responsibilities, and then to rearrange the classes, we need to understand the instances, we need to understand the packages, and the base for all the class diagram is to complete the object diagram. This the part basic we are going to cover. Basic the chapter for this, the content for this chapters are very less as compared to the others are short, but very important parts we are going to discuss. So let's discuss what is the object first. So what is object? Object is nothing but anything in the real world, maybe conceptual part or maybe an imaginary part, we are going to call as an object. And how to represent the object? Simple rectangle is the notation to represent the object in UML. This part, that Max Miller, it is called as what, object name, and from which class it is withdrawn, we are going to call it as a class. So person is the class and object is Max Miller. This is unnamed object, this is named object. So it is, object is nothing but anything in the real world, or maybe a conceptual part, or maybe an imaginary part, we are going to call it as one object. How to represent the object? These are the simplest notations. Object, this is unnamed object, no name, but derived from the class person. Object has attributes. So first name Max, last name Miller, date of birth mention. These are known as attributes of the particular object. Is it clear? Okay. Next, object diagram. So objects, those who are interested to interact with each other for a specific purpose or specific operations coming together, I am representing them with some links. I am calling this simply as an object diagram. So what basically we need to do? We need to identify the object. Object is nothing but simple anything in the real world, or maybe in a conceptual part, or maybe an imaginary part. We are going to call them an object. How to represent the object? Simple rectangle is the notation to represent object in UML. So we have to just represent the objects. and how they are going to interact with each others. Their interactions will be represented by the relationship, will be represented by the simple links. Showing them, we are simply call them as what? Object. So this is just an object from the class student Helen Lewis. The course, this is also one more course, OOM, Object Oriented Modeling. Just understand. From the course, I have selected this particular course present semester, and just this particular student Helen having the attribute Lewis, date of birth, then it's a number, attending this particular class. So I'm just representing it in the form of one object diagram. So this is the simple object diagram. Just take a snapshot of this. You can represent it in UML by using the UML. The same notations whatever we have discussed so far. Using this, you can represent the object diagram. So you might be aware we are using Star UML software. Select this. Keep by default rational approach. Okay, and then always make an habit to save. So I'll save with unit 4. Whatever the demo we will do in this chapter, we will keep as a part of a unit 4. So keep it saved as a unit 4. Okay. By default, the entire part of this we will do structural modeling inside the logical view. So right click, add a diagram and select the diagram. So if you see here, there is no need to have a separate object diagram. Everything will start here with class diagram. Is it clear? So I can show it with simple class diagram. Just for the simplicity, I will give the name object diagram just for my purpose, object diagram. Okay, select this, double click. Okay, logical view, add object. From this part you can add the objects over here. So this is class. I will not add a class, I will add an object. So select the object, this object. Okay, okay, I'll select this object 1. I'll give the name that is Rohit. And I have derived it from class ty CSE ty CSE a division. Okay, see here, this is object. Okay, with respect to this object, you want to add some attributes. Select this, add attributes. So attribute I will add over here. Okay, so I have added the first as a is date of birth, and second attribute I will add over here I'll say simply as a name. Close this. So Rohit, his name, date of birth. In this way, I can add different objects. Okay, so I just made a copy paste. Here I will make changes. Rohit. Then I will add Ravindra. Like this. You can make different classes over here. I will add one more object over here inside this logical view. Add object, drag and drop object 1. I will say Hardik from class TYCSE A division, having an attributes. So add attribute link. I'll say name, add attribute link. I'll say date of birth. Okay. In this style, we can add different objects. Now, once you can able to find out the object with respect to the particular project or with respect to particular task, once you could able to identify the objects, you need to next part is you need to decide their relationship. So here the basic relationship in object diagram, we can start with simple link option. You can able to find out the link option over here. Select this, simple connect this. This is I'm calling as what? Link. This is not an association. This is link, though it is looking like association. See, this is a link. Just for the simplicity, I'm giving the name over here, link, just to connect. I am not aware about what type of relationship it is. I'm just connecting it with a link. I have one more association relationship, basic part of a relationship. Connect elements only. So as link relationship is there, so it is not allowing me to perform the relationship. What I'll do, I'll make one more class over here, same, where I will use association relationship. Now it is allowing me the same object. It is allowing me. Getting? So when you are not aware about the type of relationship, what is there going to on, at that moment, simply select the relationship. I'm calling it what? Linked relationship. Okay. Okay. So this is what basic idea regarding the object diagram. Drop and drag and give the attributes, provide them scenarios. So I'm calling it simply as a link. So whenever we are going to run with an object diagram, we will start with a basic relationship called as what? Links. Now, once you have done with the object diagram, from object diagram only we are going to draw the class diagram. So this is the simplest way to complete the class diagram. Again, as I told to you, there are different ways to perform or different styles to complete the diagram. But the basic way to complete the class diagram is after completion of object diagram. Rather, I can say no need to draw the separate object diagram. You can represent the object diagram interacting with each other in a proper sequence. So I'm calling it as what? Sequence diagram. So basic idea is to complete the sequence diagram first. After sequence diagram, you can complete the collaboration diagram. And after the collaboration diagram, just looking towards the collaboration diagram, you can complete the class diagram. So once you complete the class diagram, your your structural view will be completed. But as part from the syllabus we are running with, but while we are performing the practical implementation of the demo parts, the basic idea that we need to take into the consideration is object diagram. No need to draw the separate object diagram. We will represent the object diagram that are interacting with each other in a proper sequence called as what? Sequence diagram. Sequence diagram, then automatically we will get collaboration diagram, and from the collaboration diagram we can go for the class diagram. This was the simplest scenario that we need to take into the consideration. Okay, now as part of a syllabus we are moving ahead from the object diagram to the class diagram. How we will move? So we will move like this. So individuals of the systems have identical characteristics and the behavior. So class is nothing but a construction plan for set of similar objects of the system. So objects which are having some same properties or some same or common attributes, we will represent them into a proper class diagrams. So objects are nothing but instance of the class. That part, that definition also we have discussed in the last lecture. So object are nothing but instance of the class. One more simplest way is what we can say, class is nothing but collection of similar objects. So I'll just combine the similar objects to represent one class. And as per the definition, object always exists or object has an existence with reference to class only. So I'm calling it what? Objects are instances of class. Remember this. And how to represent the class? The class will be represented again with the rectangle, but here we will represent it in three compartments, where the first compartment will talk about the class name, second compartment will talk about the attributes, and the third part we will talk about the operation. But in object part it was missing. In operation part was not there in the object representation. It was just a simple rectangle having name and attributes. But in case of a class, we have three compartments, three different compartments. The first compartment I am calling as what a class name. Second compartment I am calling this compartment, this part. There is no limit regarding the attributes operations. So for example, I am considering the class called the course. So the name is string. The course has a semester time. Then hours, 20 hours, 30 hours, 35 hours, 40 hours, 45 hours. Then name we can give for example, OOMD class as a course. OOMD, Object Oriented Model Design, is one of the course that comes in the semester. You can mention the semester 6. Operations, how much credit it is, how many lectures it is having, and total GPA, that is the score you will able to give in the OMD. For example, you can mention over there. Then this part will represent the most important scenario to understand what is the class and how we are going to work with the class. So when I am talking about the first part, so let's see first part as a visibility. So the class will be represented in a simple rectangle format. This is I am talking about the attributes. So I am calling it as what? Visibility. So name of the class is person. Then first name string ABC, last name XYZ, for example. Then date of birth. So here you can see this plus, minus, hash. So what it does indicates, so this plus indicates public. Everybody can able to remember. This minus sign indicates private, only that object itself. Why I'm going to tell this? Because whenever we are going to discuss about inheritance concept, that is what deriving some properties or some attributes from parent class to their child class. So or even in some case of interface operations, we are going to use some properties of already defined class into their child class or into at a same similar level also. So at that time, based on the type of attribute properties we can use. So plus means public, minus means remember private. That hashtag we will call it as a simply protected class, and this navigation talking about the packages. So class that are in the same package. So I can delete option. This is I'm calling as what delete options. So this is about the visibility. Then next is what? The way we were going to take derived attributes. So attribute value is derived from other classes. From example, age. So age will be calculated from date of birth. So this date of birth and the present date will be compared, and automatically today's his or her age will be calculated. So this will be derived entity from attribute date of birth. So will be represented like this, black we can say backslash, simple to understand. This is derived attributes. Next is the name. So names of the attributes what we are giving is the standard formats we are using. So first name, last name, you can see over here. Date of birth, address, the name, then age, password, person numbers, name. Now next, attribute syntax type. Whenever we are going to give the syntax, so we need to remember as per the programming language parts. So for example, these are the user defined classes. Data types are known as primitive data types, which will be as the name suggests primitive. You are already aware, so I'll not waste much of time on that part. So primitive, what are the primitive data types? It's very simple. Predefined primitive data types are like integer, then string, boolean, unlimited natural numbers. These are the predefined primitive data types. Then user can define inside the primitives, or maybe a combination, or I'm calling it as what, composite data types. Enumerators we can use like float, date, academic degrees, etc. So these are the nothing but attribute types called based on the type of a syntax. It may be useful while you are declaring the attributes of the class. Okay. Next is multiplicity. As the name suggests, multiplicity, we are going to discuss the relationship, one-to-one relationship, one-to-many relationship, or one-to-exact relationship. That relationship will be discussed inside the multiplicity. So it comes with like default value as a 1. Notations we can represent it minimum to maximum. There is no upper limit. So minimum to means no upper limit means hash, sorry, this asterisk mark represents there is no limit, unlimited rather we can say. Then next is the default. In case default attributes you can use, if the attribute value is not set explicitly by the users, we will call it as what, default value. We can take into the considerations as a part of a combination, or simply maybe a combination of string plus numbers, or maybe any other special character also. So I'm calling it as what, simply default value. For example, in case of password, PW123, that you can read as a default value. Then property, these are the predefined properties. Like I just want to provide a read-only property or a unique property, non-unique properties, ordered, unordered. This is basically talking about what we can say data structures, the way you used whatever the possibility of the data and data handling part that you can do as a part of a attribute syntax properties with respect to the particular class. Now after this we can focus on the next part called as what, parameters. So parameters will be discussed like based on the attribute types and declaration of the parameter, like in parameter, out parameter, inside outside parameter, in out parameter. These are the discussed over here. So get name, just like do get, do post. So based on what things you are taking from the user side regarding the dynamic scenario I'm talking about, runtime values what you are going to take, and based on that you can discuss the different parameters like in and out parameters. These are the class variables and the class operations. We will discuss inside the class diagram. No problem. See, this is the way. Just forget this UML notation at this moment. Just concentrate on this part at this moment. So this is class, and you have given the name class person. Open the curly bracket. Then you are giving some parametric operations over there. So first name, last name, attributes, public, public. I'm giving this. So public I will be represented as a plus. Private I will be represented with minus sign. Then protected I am calling as an hash. Okay. So this is the way you already aware about this, how to declare the class with variables and operations. So see here, operations and this part. So this will be represented, this entire part will be represented like this. Rectangle with three compartments. First compartment as a simple class name, second compartment as an different attributes, and third compartment as an operation. So class name, class variables, attributes, and class operation. Operations means how your class acts and reacts. So we are calling them simply as a methods. We are calling them simply as a behavior parts. Okay. Now the way we will represent it. So basic idea I said only the course, but in detail, the way I'm moving towards the detail called as what? Specialization. The course has attributes like name, semester, hours. Then course must have some kind of a credits. So I'm just talking about its properties. I'm going in detail and more detailed part I'm getting as a fine grained parts, you can say. So exact detailing parts, the way I'm going to declare the class, you can remember this. Just focus on this part, understand this. Specification of a classes, different levels of detail. This is just a simple, I said only the course, but course with attributes, operations, and the course in detailed. So I'm calling it as what? Fine grained. Each and everything I have defined with the proper attribute types, then parameters, then I have assigned some values. So just represented in a specific diagram. Just kindly go through this. If any doubt, please let me know. Any doubt, any query, any question, whatever the part I have covered so far, if anything there from your side, please let me know. Okay. Is it clear? Okay. So let's move to the next part. We are going to discuss about the different types of relationship. So basic type of relationship I'm calling as what? Simple association relationship. So let's focus on the two classes are there. For example, one class is a professor and the second is a student. So I'm just representing the relationship. It is called as what? A basic association relationship. There is no arrow means bidirectional relationship, and if arrow comes, it is a unidirectional association relationship. So no arrow, bidirectional relationship. This is the best practice, bidirectional. Either use this or use this. This is unidirectional. This one is unidirectional. And this one is bidirectional relationship. Best practices to represent the UML notations. Java notations like this you can represent. So this is simple UML notations, preferable I'm calling. So class professor, inside the class professor, I have represented the class student. So lecturer, professor has to be associated. So this is in what we can say the development perspective will be like this, and this is designer's perspective. The software designer will perform like this, the simplest relationship, and will be inside this as I am discussing the student class inside the professor class. So I have just mentioned their parameters. Exactly. After the association, we need to think about the one more type of relationship called as what? Multiplicity. This multiplicity is talking about the exact relationship. That is how one class is associated with another class. So in that style, I can represent the multiplicity. So the number of objects that may be associated with exactly one object of the opposite side. So this is just lecture assignments. So one lecture, minimum one lecture issues different many assignments. Inside one lecture you can have many assignments. So one lecturer can gives either one or can conduct one lecture or many lectures like that. So inside this the role parts. So multiplicity, simply remember more than one or maybe undefined numbers, not only more than once, any undefined numbers. Accordingly that you can resize it. So I'm calling in terms of multiplicity. The next part is what? Roles and their responsibilities. So person, maybe an examiner, will be deciding the roles, the responsibilities, and that roles responsibilities we will represent. For example, this is the one class, husband, wife, you can represent. So child, listen, I have just represented person married to. You can understand this. This unarray association means more than one relationships. So inside this exam and student you can understand this. Their types, the way they will execute. Next is association class. So this association class will provide attributes to the relationship between the classes rather than to a class itself. You can see here simplicity idea. This is just in a contract. Can be discussed to define their relationships. So I'm calling this simply as an association class. This is association class versus regular class. A specific student can enroll for one particular study program only once. So one can program. So regarding enrollments, one program only, and where student can have multiple enrollments for one and the same study program. Further, it is in more simplified way or in more simplified association style you can discuss this. So inside this we can have different associations like unique, non-unique, then no see here, no duplicates or unique ways to understand is the way you will work out the programs. This is simple association, where I will make sure about the unique representation. Then next, one more type of relationship is aggregation. As the name suggests, aggregation is nothing but special form of association. When I am going to represent the relationship between whole and part, I am going to use the aggregation. बघा लक्षात घ्या, जेव्हा आपल्याला दोन वेगवेगळ्या पार्ट्स किंवा ज्याच्यामध्ये आपल्याला एखादा सब पार्ट असेल किंवा तो त्याच्याशिवाय असू शकत नाही, असं स्ट्रॉंग किंवा वीक रिलेशनशिप, whenever we are going to discuss, we can use, there are the two types for the aggregation and composition. Aggregation is talking about the weak relationship, where the composition will talk about the strong relationship. So it is known as part of relationship, is a part of relationship. So see here, this is shared aggregation. So we will take simple example to understand about this composition. So when we can say about the car and tire. So for one car, there may be a possibility of a 4 tires. Getting? And when I am talking about this diamond and this multiplication, this is aggregation and this is composition. Strongest relationship we can represent with the composition. So this is composition, this is aggregation. So without tire, is it possible to drive a car? Definitely not. Like that we can discuss. Shared aggregation and composition. So aggregation is weaker type relationship and composition is a stronger type of relationship. See, a tire cannot exist without a car. A tire can belong to multiple cars. Type of tire, car has one or two types of tires. Several cars may have the same type of tires. So based on type of a car, you can discuss this. So simply remember this part as a composition, this part as an aggregation. Next is generalization. So you can discuss the generalization relationship is nothing but simply we can talk about the maintaining the parent-child relationship. Remember this part, A, B. So this will be the arrow side will be always towards the parent class. So here the person as a parent class, or in consideration with our class example, we will call this as a super class. Super class has two subclass, employee and student, and employee have further two more classes as their child class, like a professor and secretary. So secretary is an employee and a person. So professor, rather sorry, as a secretary is an employee also, as a part of the person also. So this is I'm calling as a generalized. So I'm saying simply secretary is a person. It's or simply it's a person. Mr. A is working as a secretary, but in generalize I'm talking as a person. The next part in specialization way I can say Mr. A is person who is an employee also. In more specialized way I can say that he's a secretary, so he's an employee and as an person also. This is generalized, specialized part, the way we can represent, the way or the levels. Even you can take example like that. Mr. Anil Ambani, I will say as a super class, Mr. Anil Ambani having 1.2 crore properties. Just for example, he is having much more than that. But when I say Mr. Anil Ambani having 1 crore in his saving account, that becomes more specialized way. So the way if you are moving down, and down, that becomes the specialization, and reverse is when you are moving up to the next level, to the next level, to the super class level, we will call it as one generalized way. Generalization and specialization. These are talking about the way we are moving from lowest level to an highest level of an association. We can discuss this, we can without generalization. Next part, while we are going to draw the class diagram, It is always possible. For example, to understand the class diagram is to understand the object first. Then after the objects, you need to design some attributes. You need to identify the specific operations of that on object. And once you could able to identify the objects with their specific attributes, objects with their specific operations, then you can easily draw the class diagram. Let's take example. The library management system stores users with their unique ID, name and address, as well as books with their title, author and ISBN number. Uh, so there may be different user. So what about N Foster? It is an user where I can use the different scenarios for the understanding purpose. Okay, so let's take an example of university information system. But before that, we will see the library management system. So I will select this as a logical view, right click, add a diagram, select the diagram, class diagram, give the name library management system. So what we said, we will have two classes over there. So I'll just add the class. Okay. The first class that I will add over here as a part of the simplest scenario I am considering over here, that the first name is the book. The first class I will deal with book. So that book class have some attributes and properties. So I will say attributes. I'll add operations. Okay. So attribute, what I will add, the first attribute regarding the book is title. So I can say edit and I'll give the name title, okay, as an attribute name. Okay. Then I can say author. I can add one more attribute. So insert. I'll rename it edit author. The specific book has ISBN number also. So I'll consider that also. So I'll consider as ISBN as a number. Okay. Operation part, I will just add operation. I'll not consider any operation at this moment. Okay. So this title, I will make visibility as a public. Then all I will make by default as a public. Okay. So close this part. This is with respect to book. Now with respect to user, I will add one more class over here whose name will be user. And this user class has common attributes over here. So I will say that attribute as integer ID. So I will say simply ID for the understanding. Then I will add one more attribute as his name. So I will say simply as name. I will add one more attribute as address. So select this, edit this. Okay, so address, this is the part, and by default I mention this plus, that is private. If you want to change any of them, you have to select this attributes, which attributes values you want to change. You can change, for example, the template parameters, operations, attributes, attribute types you want to change, you can change over here. Here visibility you can make, for example, protected, so protected I can say, private you can say as a private, and if you want to make it inside the package with one more user, so say simply package. So public, private, protected and package part with some derived attributes. I will continue with the public. Make a changes, save this. Then you can use any of the relationship from this part. See, there are the different types of a relationship. So association, directed association, aggregation means is a part of a relationship. Weak, this one is a strong relationship. This one is the generalized relationship. This is the dependency type of a relationship. This will be realization relationship. So this part will be discussed in detail with upcoming parts. So this is the way you can able to add some simplest scenario over there. Okay. So once you could able to complete this part, we can discuss the next part. That is example I am talking you. A university consists of multiple facilities which are composed of various institutes. Each faculty and each institute has a name. An address is known for each institute. Each faculty is led by dean, who is an employee of the university. The total number of employees is known. Employee can have social security number, SSN, and email address. There is a distinction between the research and the administrative personnel. Research associates are assigned to at least one institute. The field of the study of each research associate is known. Furthermore, research associates can be involved in project for certain number of hours, and the name, starting date and the end date of the projects are known. Some research associates hold courses, then they are called lecturers. So the courses have unique number, name and a weekly duration in a particular hours. So that I can represent this in the simplest format. So let's draw the class diagram for this problem statement. This is the problem statement. I'll explain this problem statement and you can draw the class diagram. So what are the steps? I hope you understood. If you want to read it one more time, just read it. I'm taking 1 second, 1 minute pause over here. Kindly read it. Okay, so the next step after completion, after reading the problem statement is we need to understand the classes, different classes. So the different classes will be there, like a university consists of multiple facilities, faculties, which are composed of various institutes. Each faculty and each institute has a name. So I can say faculty institute. Address will be an attribute. Each faculty is led by dean, means the same faculty assign different roles, maybe as a lecturer, etc. So each faculty is led by a dean who is an employee of the university. So we will have an employee class. Okay. Total number of employees known. So exact number of employee will be specified. Having an attributes. So that employee will have an attributes like SSN, that is social security number, his name, his or her name, email address, and there will be a distinction between the researcher and the administrative personnel. So we will have two separate classes over there, administrative and research. Okay, research associates are assigned to at least one institute. So research associated will be associated with at least one institute, at least, maybe more than one institute also, like that. So dean has no further attributes than any other employees. So except this part, this will be just in a role they are going to play, maybe as a part of a faculty. So we can assign this in the detailed wise. See here. This is the way you can take the note of this, take the screenshot and add this in the simple diagram. Whatever the part I am showing to you, you have to prepare the specific class diagram to understand its employee, understand its associated parts. So these many classes will be there. So consider these classes. So simply consider these classes. Take the screenshot, simple screenshot of the same, and save the screenshot with you. So just very easily you can add the remaining parts. Okay. Next, after identifying the different classes, just read the problem statement once again and define the relationship. Maybe association or maybe generalization. For example, they can say simple employee. That employee may be administrative employee, or maybe research associated, or maybe simple dean, or maybe a lecturer. So lecturer is the one who is part of research associated. So simply remember this as a part of a generalization relationship. Next, you can say the institute ones, the relationship among the faculty and the institute. So at least the faculty may be associated with at least one institute. An institute may have more than one faculty. So minimum one to the n undefined numbers. So university consists of multiple faculties which are composed of various universities. So this composition to show the existence dependency. So stronger relationship, faculty and the institute. This is the whole part. This is the part of this. So faculty is part of the institute. Then each faculty is led by a dean who is an employee of the university. So you can discuss this. So in the leads relationship, the employee takes the role of dean. You can just read this. Again, field of the strings, you can assign the relationship as a part of researcher associates and their assigned values. So I can say that the research associates are assigned to at least one of the institute. where you can discuss this as a shared aggregation. Shared aggregation means we can say a weaker type of relationship, that research associates are the part of the institute, but there is no existence dependency to understand the situation. Okay. Now next is again further what we can say, the research associate can be involved in the project for certain number of hours. So we are going to assign particular hours. Based on the number of hours, we can discuss their scenarios. So just see. And the last part is what we can say. Some research associates hold courses, means they are going to conduct some classes, then they are called as a lecturers. So relationship between employee basically who is associated as a research associate. So research associated will be assigned some load regarding conducting the lectures for one specific course, means weekly 4 hours, weekly 8 hours for one particular subject. So this will be represented as identifying the relationship. So this is what my complete class diagram, whatever the problem statement was there, and based on the problem statement, my class diagram is completely ready. So this is university, whatever the example given, based on that example you can take this. So all of you take the screenshot of this. All of you just take the screenshot of this. Reply something yes, no.
Yes, sir.
Very good, very good. Take the screenshot, and when I say I hope you all have installed the star UML. Simply draw the same diagram in the star UML. The simple part, no need to worry. Just looking towards the screenshot, whatever you have taken, complete the class diagram. Is this clear? And after completion of the class diagram, we can see how to generate the code. Even last lecture also we have seen how to generate the code. So once you could able to draw this class diagram, I will show you how to complete the code generation part. Is this fine? Shall we take a pause here? I'm giving the time to complete you the class diagram. After the class diagram, I will once again I will demonstrate you how to complete the code generation. That is the further part, because today's attendance is very less. Only 30-35 students are there, almost 60% attendance. So before going for the next part, I suggest is today we'll take a pause here. Take your time and complete the class diagram for the session today only. Will it be fine? Reply something yes, no.
Yes, sir.
Okay. We'll take a pause here. I'll take the screenshot, or just simply give your attendance fast. Your attendance, roll number 1, 2, 3, roll number 3,
Present, sir.
4,
Present, sir.
okay, 4, 5,
Present, sir.
6,
Present.
7, 8, rule number 8, 9, 10, 11,
9 is present.
11 present, sir. 11
12.
present, sir.
Okay. Those who are missing, just give me the numbers at the end. 12,
13 present, sir.
14, 15,
Present, sir.
16, 16, 17, 18, 19,
Present, sir.
20,
20 present, sir.
21, 22,
Present, sir.
23, 24,
Yes, sir.
25,
Present, sir.
26, 27,
27 present, sir.
28,
28 present, sir.
29,
Yes, sir.
30,
30 present, sir.
31, 32,
Present, sir.
33, 34,
Present, sir.
35,
35 present, sir.
36, 37, 38,
37 present, sir.
39,
39 present, sir.
40,
40 present, sir.
41,
Present, sir. 41.
42,
42 present, sir.
43,
43 present, sir.
44,
Yes, sir.
45, 46,
Present, sir.
47, 48,
Present, sir.
49,
Yes, sir. 49.
50, 51, 52, 53, 54,
Present, sir.
55, 56, 57, 58,
Present, sir.
59, 59, 60, 60, 61, 62, 63,
Present, sir.
64,
Present, sir.
65,
Present.
66, 67, 67, 68,
Present, sir.
69,
Present, sir.
last 70. Any change there?
Sir, roll number 4 present.
Sir, 26
present.
Roll number 4.
26.
Okay.
Yes, sir.
26.
Sir, roll number 16 present.
16.
Yes, sir, 20.
Sir, roll number 36 present.
Roll number 36. Next.
69 present, sir.
69 is present. Okay.
47, sir.
47. Who is 47?
$27 म्हटलं sir.
Hmm? Any other correction? Okay. So what the task I have given, the simplest part is take the screenshot of this slide and draw the same class diagram using star UML. Now why I'm telling this, once you could able to complete this, I will show you how to generate the code, means the coding generation, that process called as what? Forward engineering. So take a half an hour or whatever the time you have, be ready with your class diagram. How to draw this? So start the star UML, select this logical view, right click, add a diagram and select the diagram as class diagram. Give the naming convention, follow the same. University management, simply CMS you can say, simply give the name CMS, double click, select this particular class, drag and drop and only perform the renaming parts and use the proper relationship the way they have represented. जसं ह्यांनी दाखवले तशीच्या तशी सेम डायग्राम ड्रॉ करा. त्यानंतर आपण काही चेंजेस करून कोड जनरेट करणार आहोत. त्यामध्ये काही चेंजेस होत असतील तर ते आपण समजून घेणार आहोत. इज दिस पार्ट फाईन? लक्षात येते मी काय सांगितले ते? Reply something yes, no. Yes, reply something yes, no. Shall we take a pause here? Okay, next lecture we will discuss how to generate the code. Once my class diagram is ready, how I will get the code. That coding part we will discuss into the next lecture. Till then we'll take a pause. If any doubt, any query, you can ping me directly at any time. Thank you all. Thank you.